all squared away with this before we start adding to it. Today we're just going to add a little bit. This is largely a review of what we did yesterday with a couple of minor little adjustments. So number one, the whole idea that we started and introduced yesterday is the idea of trigonometry. So the word trigonometry, so that's what you're putting in here, is Greek for triangle measurement. All right, so they're the ones who kind of understood this, developed this to measure heights of buildings, distances from different things, and then the Greek trigonometry stands for angle or triangle measurement. All right, Maria? All right, number two, trigonometry can then help us solve for the missing side lengths when you don't have enough sides to use the Pythagorean theorem. So what that is alluding to, if I give you a right triangle, so here's our right triangle, and let's say this is 4, and I wanted to know how far away I am. So if I'm standing here, this is a building here, we want to figure out how far that distance is. All right, we can't do that without the Pythagorean theorem if we don't have at least 2 sides. But if I know what this angle is, and this is what we get to in the next section, if I know one angle and one side of this right triangle, then I'm going to actually be able to figure out what that is without having to use the Pythagorean theorem. Okay, so trig allows us to, again, work with a lot of triangles. So then number 3, what we talked about yesterday, and just making sure we're clear on this, because as we started going through this in first period, they were not necessarily as clear on it as they thought, is all these words and how they relate to these triangles. So what we're going to start with is if I gave you this angle and I ask you to now label those 3 sides with words like hypotenuse, adjacent, and opposites, where would those words go? So if we look at these here, the one that you have seen for a very, very long time is that opposite of the right angle, which is this side over here. You've known this word, you've dealt with this word a long time now, is the hypotenuse. So whatever is opposite of the right angle, that is still your hypotenuse for all of these trig relationships that we've been working with. Then if this is our angle that we're referencing, okay, so we always want to know what angle we're dealing with. If that's our angle, the angle that is opposite, or the side that is opposite of that angle, is exactly what we would have just said. That's the opposite side. So we start doing opposite over adjacent, opposite over hypotenuse, so on and so forth. That's your opposite. And then when we look at this angle here, there are 2 sides we talked yesterday that are adjacent to this angle. This side here and this side here, both of them border that angle. The one that we call the adjacent side is the one that's not the hypotenuse. We've already labeled this one, so it is the other one that we call the adjacent side. All right. So with that, real quick, label the 3 words on that second triangle. So if this is now our reference angle, label those 3 sides real quick. All right, we should have, here's your right angle. So the one that you've known for a very long time is the hypotenuse. So that is the one that is opposite of the right angle. And then if this is the angle we're talking about, the one that is opposite of it should be over here. And then if nothing else, by the process of elimination, this guy right here has to be what we would call the adjacent side when we start doing all of these little ratios. Okay. Then yesterday we talked about what those 3 most common trig functions are: sine, cosine, tangent. You saw that they're more common enough to be on the calculator. They have their own keys on those calculators. And then we talked about how the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And then the tangent is the opposite over the adjacent. And if we knew how to label these triangles, then we can just look at the triangles and identify what each of those lengths is. All right. So that's what we're going to do here. So for number 5, I want you to simply find the sine, cosine, and tangent of angle A in these triangles. So start with number 5. Let's see where we were at. There was a false sense that we knew this first period. So hopefully you guys are better than first period. And we actually do know this. So do those three. All right, crossing my fingers now. No questions on the homework, so we're feeling good about this. So we should be able to call on anybody, right, Maria? And they should have it right. Should. I'm going to start with Sarah. Okay, nice gal. Usually pretty reliable when I call on her. Usually has the right answer. We're going to see. So Sarah, what'd you find for the sine of angle A? All right, is 4 over 5 correct? Good. The opposite side over the adjacent side. So the opposite of A is 4. Not the adjacent. Over the hypotenuse, which is the 5. All right. All right. Cosine of angle A. I'm going to pick Nadia. I'm going to build confidence in myself that we got it. Pick on very reliable people. So Nadia, don't let me down, Nadia. What do you got, Nadia? What is the cosine of that angle? Good. 3 over 5. That is the adjacent side of angle A. That's the 3. The hypotenuse is a 5. All right. And then last but not least, Hannah T. Won't let me down. What did you get for the tangent of angle A, Hannah? Good. That is the opposite side over the adjacent side. The opposite side of angle A is 4. The side that is right next to angle A is 3. So those are our 3 values. Okay. All right. So far, so good. Number 6. Do number 6. All right. 6. Again, sine, cosine, tangent. We haven't talked about the little acronym next yet. That's on the next page. So hopefully we're kind of remembering this without having to say it or write it. If I want the sine of angle A, so here's angle A. Myrna. What do you got, Myrna? Good. Opposite side is 12. And then the hypotenuse is a 13. So 12 over 13. Okay. Cosine of angle A. Zaria. We're on a hot streak, Zaria. Don't let me down. Okay. I put that also. So 5 over 13. Angle A is here. The adjacent side is the 5. The hypotenuse is a 13. All right. So far, so good. All right. And then when I do the tangent of angle A, Fabian, what do you have for the tangent of angle A, Fabian?
12 over 5.
Good. 12 over 5. The opposite side of that angle is 12. The adjacent side is 5. All right. All right. So far, so good. All right. Number 7. Do sine of. Try to leave some room here because we're going to do a little. I'm going to add to this one. Do number 7. Maybe a little more time here. Looks like people are still writing. See if we can go 9 for 9 here.
Maybe we'll just let Mr. Pena call on you first and see if you can keep the streak going.
I'm waiting. I'm waiting to call on Riley here. Just the right one.
Got a special one for
Yeah,
you.
yeah, special one lined up. All right, Sophia. If I ask you for the sine of angle A, what do you think, Sophia? Would you like a little guidance? Okay, so the sine, when we did this, it's up here if we ever need to reference it, and then we have an acronym for this. The sine is the opposite side over your hypotenuse. So if we want the sine of angle A, so this guy right here, which angle is like opposite of it on the opposite side, away from it? So that has to be our numerator. So we should have the 4 root 3 as the numerator. And then what of these two guys is your, good, the hypotenuse is 7. So 4 root 3 divided by a 7. All right. Good. We're going to count that as a win. All right, Mark, cosine of angle A. What do you think here, Mark? Good. The adjacent side is the 1. The hypotenuse is a 7. So the cosine of angle A is 7. And then last but not least, the tangent of angle A, Catherine, is what? Good. 4 root 3 is the opposite side. And then the tangent is the opposite over the adjacent, which is a 1. Okay? All right, so far so good. Don't flip the page, though. You have plenty of room down here. What I want you to do now is, and this is what is one of the things that's new, and I didn't write this good for you to show that. Label this angle B. So the other angle that's not the right angle and not A. Label that angle B, and then give me the 3 different trig functions now. So sine of A, cosine of A, and tangent of A. Or B. Yeah. Thank you. So now, if this is angle A, what angle is the opposite of angle A? Or, sorry, what side is opposite? Yeah. Well, if it's angle B, what side is opposite? So that's going to be different right off the bat. If you're going to do the opposite of A, you're going to put that as the opposite. If you're going to do the opposite of B, you're going to put that as the opposite. It's still the same ratio. But now that we're at a different angle, the opposites and the adjacent have to change. Let's do this first. All right, number 7. Now we're going to do angle B. So we are down here. That's our angle. So now adjacent, opposite, hypotenuse are all based off of that guy. So Destiny, what'd you get for the sine of angle B? Good. The opposite side was a 1. The hypotenuse is a 7. All right. All right. Hannah D, cosine of angle B is going to be what? Good. The adjacent side of angle B is now this 4 root 3. And then the hypotenuse is still going to be that 7. All right. And then last but not least,
I told you. 1 over 4 square root 3.
oh, this tangent of B is what? I know, Riley. Riley is what?
I'm sorry. 1 over 4 square root 3.
Okay, we agree with that. All right, good. However, so good, Riley. Very good. You're very smart. However, go to the back page. So go to the very back page. Go to the bottom where you have a little bit of room. So down here where there's a little room. We talked about a very long time ago. We did it basically for 2 days, and we didn't necessarily revisit it. We haven't had anything pop up that we would need to revisit it until now. But what we talked about is we can never divide by an irrational number. The square root of 3 is an irrational number. Irrational just means if I do the square root of this 3, notice how this decimal doesn't repeat, and then I promise it goes on forever. It's just the screen ends. We can't divide by an irrational number. All right, that is impossible. So if you remember, what we did is something to this so that we wouldn't end up with an irrational number in our denominator. All right. So first things first, don't write this down, but do we agree that if I took anything and multiply it by a 1, don't we get the exact same thing that we started with? Yeah. Okay. So when we multiply by 1, nothing changes. But what we did when we did these, we didn't multiply by the actual number 1. What we would look at, here is our problem in our denominator. It's the square root of 3. What we did is we multiplied both the numerator and the denominator by a root 3. So this I do want you to write. All right. Because isn't this still here? Root 3 divided by root 3, isn't that still nothing more than a 1? Anything divided by itself is a 1. All right. Then what we now do is we actually do this product. So I'm going to do 1 multiplied by root 3. That's how we multiply fractions. You just multiply across. And 1's a radical, 1 is not. So I'm just going to put the 1 in front and multiply it by a root 3. In our denominators, we're going to multiply straight across. Now that these are both underneath the radical, we can go ahead and multiply those together to get a 9, but it needs to remain underneath the radical symbol. All right. If we do this correctly, we should get rid of the irrational number from our denominator. What does our denominator in this case now become? What is the square root of 9? 3. So this, if I did the square root of 3 divided by 3, is equivalent to 1 over root 3, but we no longer have the weird irrational number in our denominator. Okay? So one more. Let's do, I'll do 5 up here. And I think I did root 6 last period. So let's now do 5 divided by a root 6. Our issue in this one is the square root of 6. That is an irrational number. So what we're going to do is multiply by a root 6 over a root 6. That's what we're trying to get rid of. So on the top, the 5 and the root 6, we can multiply them together. You just can't actually do like a 5 and a 6 and get a 30 anywhere because one's underneath and one is not. So we just write it as 5 times root 6. However, in our denominator, these are both underneath the square root, so we can get a 36 out of that. So we now have 36 underneath the square root. The numerator, nothing we can do, but now our denominator is just a simple old what number? 6. And we no longer have the irrational number in our denominator, okay? The reason that's going to be increasingly important with all of these, look at all these fractions that we just did here. And for the first time, won't be the last time, the one that Riley just gave us, don't we have a radical in our denominator? So go back to problem number 7. We now need to rationalize this, okay? This you would not want to leave as your final answer. So what we're now going to do to that answer for the tangent of B, since the square root of 3 was our irrational number, just like we did on the 2 on the back, we're going to multiply by a root 3 over a root 3. When we do that, when we multiply fractions, you just multiply numerator by numerator. So a 1 times a root 3 is just a 1 root 3. Denominator now, just kind of be aware of what happens here. There is a 4 in front of this one. There is a 1 in front of that one. So we're going to multiply the numbers in front together. So that's just going to give us a 4. And then at the same time, we multiply the numbers underneath together. So a 3 and a 3 gives us a 9 underneath. So we get 4 root 9. And then again, if we did this correctly, we should no longer have a square root in the denominator. My numerator just ends up being a root 3. And then isn't this really a 4 multiplied by a what? Maria, go ahead. I was going to say you were like, so I thought you were ready to say 3. Yes. Square root of 9 is a 3. So we now end up with a 12 in our denominator. This is our simplified rational answer. Okay, root 3 over 12. All right. And you're going to see that a lot now. We have all these fractions here. We want to be able to rationalize them when that presents itself. All right. We're going to see that here in a little bit, some more. All right. So now go to the next page. We haven't used the little acronym yet, but this is absolutely something that you want to get memorized, something you want to rely on over the next handful of years when you come across this, is the whole idea of SOHCAHTOA. This gives us a nice little way of memorizing all of these. That sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And then the tangent is the opposite over the adjacent. All right. Last thing, and then we'll do a few more problems that will incorporate all that stuff, is it says some triangles may only show 2 sides. So if I look down at these last 2 problems we're going to do, 10 and 11, notice how there's only 2 sides. If I want to know the third side, then we should know that in order to do that, we can use the Pythagorean theorem. And then we'll go ahead and write what that is. A squared plus B squared equals C squared. So all the ones we did on the front page, you had all the values. It is not uncommon then to come across something like 10 and 11, where you only have 2 of the 3 sides. If I wanted you to find sine, cosine, and tangent, we need to know what this side is before we would be able to do that. So it just adds a little extra layer here. We're going to have to do the Pythagorean theorem to figure out what the missing side is. So a squared, b squared, c squared. And then what you have to recall is that the c is always your hypotenuse. The hypotenuse in this problem is what number? In this 7. So you have to put the 7 there. That's your hypotenuse. And then the 5, we'll say that it's A. Doesn't necessarily matter over here, but the hypotenuse must be C. Clean that up. So we'll get 25 plus B squared equals 49. Subtract your 25 over. B squared is then going to be 24. Take the square root of both sides. 24 is not a nice perfect square, unfortunately, so that just means we're going to simplify it. What's our nice perfect square that'll give us 24? Not a lot of options here. Yeah, 4, and then multiplied by a 6. So our b is 2 root 6. So we now know that this length over here is 2 root 6. All right. Now, these, I ask you to find the tangent of A and B. I really want you to do B's only right now so that we can get through 10 and 11. So come down here now and tell me what, again, just do B. So sine of B, cosine of B, and then tangent of B. All right, so far we're perfect on these. So hopefully we stay perfect through the end of the period. All right. Let's go, Julia. The sine of angle B, what would you tell me the sine of angle B is? Good. It's the opposite side over the hypotenuse. 5 is opposite of angle B, and then 7 is your hypotenuse. So 5 over 7. All right, if I go to the cosine of angle B, Amarian, what do you got for the cosine of this angle? So for angle B, what's our cosine value? Would you like a little guidance?
The cosine, the 2 root 6 over 7.
Good. It's a close one. But good. 2 root 6 over the 7. As long as the radical is in our numerator, we're good. So we don't have to worry about any of the stuff that we just got done reviewing. If I did the tangent of angle B, let's see here. Haley, what'd you get? Good. 5 is the opposite side, and then 2 root 6 is the adjacent side. And then what you have to recognize as we move forward, this is our problem. So we need to clean this up. All right. Do not leave that as your final answer. So in this one now for the tangent, this is where we're going to now multiply by root 6 over root 6. Move this up since that's what we're working on. When we multiply our numerators together, one's a radical, one is not. So we just have to write this as 5. I guess this is the one we did earlier to some extent. So 5 root 6. When we multiply our denominators together, I have a 2 here and a 1 there. So the 2 and the 1 multiply to give us a 2. And then the numbers underneath the radicals, we can go ahead and multiply together to give us 36. So that when we now clean this up, the numerator, nothing you can do with it. It's going to remain a 5 root 6. And then in our denominator, we are taking this 2 right here, and we're multiplying it by the square root of 36. And the square root of 36 is a good old-fashioned 6. So we should end up with a 12 in our denominator. All right. And then that's our simplified answer. That's what you would write down. All right. When we eventually get to a quiz and stuff on this. All right. Okay. So real quick, go to number 11. Let's do the Pythagorean theorem one more time. So a squared plus b squared equals the c squared. The c is an 11. All right. That's your hypotenuse. So the 11 must go there. And then we have 5 squared plus b squared. All right, go ahead. 5 squared is 25. 11 squared is 121. We'll subtract that 25 over. So that b squared is 96. And again, unfortunately, that's not a nice, perfect square, so we've got to simplify that. I'll give you this for the sake of time. It's not an obvious one. It's 36, or what? Well, 16 and 6. Yeah, 16 and 6. The 16 is our nice number. That's our 4 root 6. So we'll put the 4 root 6 on this side. And then again, just do angle B. So just, again, go through sine of B, cosine of B, and then tangent of B. So get those 3 real quick. All right. I'm going to speed you along a little here to make sure we finish. So the sine of B is the opposite side, which would have been the 5. And then your hypotenuse would have been 11. So check that one. Make sure we get 5 over 11. The cosine of angle B is the adjacent side of angle B, which is the 4 root 6. And then divided by your hypotenuse, which is, again, the 11. So those 2 are nice. And then the one I want to make sure we get to, if we now do this tangent of B, we're going to get that problem. we're going to be doing the opposite side of 5 over the adjacent side of 4 root 6. And then we just have to recognize moving forward now that we just can't leave this as our answer. Okay, so hopefully this is coming back to us. We've done now 4 of them. We want to get rid of that root 6 from our denominator. So that's what we're going to multiply the numerator and the denominator by. Across the top, when we multiply, we just get the 5 and the root 6 written as a product of each other. We can't actually do a 30 anywhere. On the bottom, you have a 4 in front of this one. You have a 1 in front of that one. So when we multiply, the 4 and the 1 will give us a 4. And then underneath the radical, the 6 and the 6 will give us a 36. So if you were ahead and got all of this done, your final answer would have been a 5 root 6 on top. And then here, I really have a 4 multiplied by a what? 6. And 4 times 6 is what? 24. So this would have been your final simplified answer for that one. Okay? All right. No homework tonight. I kind of want you to do just all of these thrown together in front of us. So we're going to do that tomorrow. You'll largely just kind of work on that tomorrow in class with somebody. We can answer questions as needed, but no homework. You're good.